To find dy dx of this problem, we have to use implicit differentiation because you cannot solve for y. When we have two y's in an equation, like a y squared and a y to the fourth, it's going to be really difficult, if not impossible, to get y by itself, especially in a form where we can take a derivative. So instead, we're going to use implicit differentiation, and that just means we're going to take the derivative of everything all at once, of x's and y, and we're doing it in respect to x. So the derivative of 1 is going to be 0. This is going to be 3x squared dx over dx, which goes away. And right now, I am going to have to use the product rule for this. This is x times y squared, so it's two different variables, so we have to use the product rule. I highly recommend you just pull that -4 out and do all this work and then distribute it back in, because especially with a negative, it gets a little confusing. So we're going to do the first, which is x, times the derivative of y squared. So the derivative of y squared is going to be 2y, but don't forget you have to multiply it by dy over dx. And that is because if you have like y equals 2x, whenever you take the derivative, you're like, hey, y prime equals 2, or dy dx equals 2, which means on this side, we are always taking the derivative of y. We just were writing it explicitly, so we probably weren't realizing it. But anytime you take the derivative of a y term, you have to put the dy over dx. Okay, then plus the second, which is y squared times the derivative of the first. And remember, we've put this out together, so the derivative of x is just going to be times 1 equals, on the other side, because we're taking the derivative of everything, -4y cubed, and again, we're taking the derivative of y, so we've got to multiply it by dy over dx. And let me clean this up here. Get rid of this over here. Okay, so now what we have to do, and the next step, is we need to collect our like terms, because we're trying to get dy dx by itself, and in order to do that, you've got to collect those like terms. But first, it's a little messy, so I like to go ahead and kind of simplify this a little bit. So it's going to be -3x squared, and I'm going to distribute that -4 to both of these terms, and that's going to give me -4 times 2. Let's go ahead and really simplify this. So -4 times 2 is going to give me -8xy dy over dx, and -4y squared equals -4y cubed dy over dx. Now, if you notice, I have two terms that have dy dx in it, right here, and I have two terms that do not. Let's go ahead and move the dy dx terms to the left and the other terms to the right, which means right now I have a -3x squared, so we're going to add 3x squared to both sides. I'm going to add 4y squared to both sides. So I'm moving these terms over because they do not have dy dx in them. So they give me 3x squared plus 4y squared. And then I'm going to move the other terms over here. I'm going to add 4y squared, 4y cubed, 4y cubed dy over dx, and this term 8xy was already over here. Now, as you can see, I've got dy dx in both of these terms, so I'm going to pull that out. I'm going to pull the dy over dx out. I'm going to factor it out. Leave me 4y cubed minus 8xy, and that's going to equal 3x squared plus 4y squared. And now I'm so close. I just need to get dy dx by itself. So I'm going to divide both sides by this 4y cubed minus 8xy, which just leaves me 1 over here. And when I divide it, I have 4y cubed minus 8xy on this side. So dy over dx is this phrase, this equation 3x squared plus 4y over 4y cubed minus 8xy. And so this is the slope equation that will give us the slope at any point on this curve. So I would have to be given an x value and a y value in order to find the slope. But this right here is a good start because it is my slope equation. Of this, it could be an application, would be if you have this curve, then you will find the equations of all tangent lines to the curve when x is 1. So they've given us a couple clues. First of all, they've given us x is 1, and they said all tangent lines. So since these curves are not your normal functions, they can actually have more than one y at every x, and I believe in this case it's going to be true. So how you would find that is you're going to plug in 1 for x and then solve for y. So let's do that right now. So if you have 1 minus 1 cubed minus 4 times 1 times y squared equals negative y to the 4th. So to simplify this, you have 1 minus 1, which is 0. So that gives you negative 4y squared equals negative y to the 4th. To solve this equation, you're going to add y to the 4th to both sides. And you'll get y to the 4th minus 4y squared equals 0. In order to solve this equation, you can take y squared out. And then you get y squared minus 4 equals 0. And that's going to give us 3 solutions if you completely factor this out. You're going to have y equals 0, negative 2, and positive 2. And so that means this one x value gives you 3 y values. So to write those ordered pairs, you're going to go 1, 0, 1, negative 2, and 1, comma 2. So since we have 3 places on the curve where y is 1, that means we're going to have 3 tangent lines. We're going to find one of those right now, just to give you an example. Oops, don't let me forget my square there. Don't want to mess up with that. So let's start with this point right here, this nice little 1, 2. So we're going to use this point first. And so we're going to evaluate dy over dx at the point 1, 2 and see what that gives us. Alrighty. So if we put plug 1 in there, 3 times 1 squared plus 4 times 2 squared all over 4 times 2 cubed minus 8 times 1 times 2. So on the top that gives us 3 plus, and that's 4 times 4 is 16. On the bottom that gives us 32 minus 16, gives us 19 over 16 as a slope. So now I have my slope. Remember the equation of a line, when I have that it is y equals m, x minus h plus k. These are my hk points right here, h and k. So I really just need my m, which I just found. Remember, derivative is slope. So now I can write my equation. So y equals the slope, which is 19 over 16, x minus 1 plus 2. And now we're going to find one more that's has a little of more of an unusual and interesting result. We're going to do this one right here, which is 1, comma 0. So for our second, because we're going to have 3 tangent lines, so this is the first tangent line. Now we're going to find this is the first tangent line. Now we're going to find the second tangent line. So we are going to use dy over dx, and we're going to evaluate that at 1, comma 0. So that gives us 3 times 1 squared plus 4 times 0 squared all over 4 times 0 cubed minus 8 times 1 times 0. And as you this gives us 3 over 0. This is a really interesting answer because this means no. And what does that mean? That means that the slope at this point 1, 0 is undefined. The slope of the tangent line is undefined. And so in order to write the equation of this line, we have to think, what does an undefined slope look like? Remember, a 0 slope, and undefined. So that means the slope looks like this. So on a graph, what would that look like? In order to illustrate this, I have imported the graph of 1 minus x cubed minus 4xy squared equals negative y to the 4th right here. And I want you to look right here is the point we're looking at. This is the tangent line at that point. So how do you write the equation of a line that only goes through the x-axis? And that is going to be x equals 1. So that is our second tangent line. We can find the third line following the same procedure. and you can do that later if you'd like. But I think 2 examples are probably plenty. All right, have a great day.